Welcome back once again to our Math 171 video series. In this video, we'll go over how to solve systems of inequalities. Here we have a system of inequalities that has three lines: y less than 6, y greater than or equal to negative 2x plus 2, and y less than or equal to x minus 1. What we must understand first is that all three of these lines represent diagonal, horizontal, or vertical lines on a graph. If you have three lines in your system, we can expect to have three lines on our graph. Now, any line that begins with simply y and contains no letter x, just as line 1 does, we can safely assume that that is a horizontal line. Any piece of the system that has both y and x will be a diagonal line. Any line that has only x and no y will be a vertical line. We don't have any line like this in this particular system, but you may see it when you try your homework. Based on this, we can say that line 1 will be a horizontal line because it has only y in it and no x. The other two lines will be diagonal. To solve a system of inequalities like this, our first step is going to be to figure out where the lines cross. This is called finding the vertices. We'll begin by setting line 1 equal to line 2. Therefore, we'll set the 6 from line 1 equal to negative 2x plus 2 from line 2. We'll try to solve for x here. This means that this positive 2 on the right will become negative 2 and it will have to move. On the left, 6 minus 2 gives us 4 equals negative 2x. The positive 2 and negative 2 now cancel out. Then we're going to divide by negative 2 on both sides. When we divide by negative 2, we will get x equals 4 divided by negative 2. And 4 divided by negative 2 will give us negative 2. Now that we have our x from setting the lines equal to one another, we have to find y as well. We're going to use our expression from line 2 to figure out what that is by plugging negative 2 back into line 2. Therefore, we will have y equals negative 2 times x plus 2. However, our x is negative 2. If we do the arithmetic, we'll multiply negative 2 times negative 2 to get positive 4. Then we'll add our 2, and that's going to give us 6. Therefore, our first vertex will be negative 2, 6, writing x and then y. So this is the vertex we found by setting line 1 equal to line 2. Now we'll continue by setting line 1 equal to line 3 and finding another vertex. So now we'll start the process again by setting line 1 equal to line 3. We will say 6 from line 1 is equal to x minus 1 from line 3. If we add 1 to both sides to get x by itself, we'll end up with 6 plus 1 equals 7 is equal to x. And now that we have our x, we have to also get y. To do that, we will go to line 3. And we'll say y is equal to x minus 1, but we know our x is 7. So we'll place that 7 in the x position, and we'll say y is equal to 7 minus 1, which is 6. Therefore, our second vertex will be x comma y, and the x was 7, the y was 6. This is the second place we can expect our lines to cross. Now we repeat the process one more time, this time taking line 2 and line 3. Once again, we will find x first and then y second. We'll start by saying line 2 equals line 3 and placing the expressions. Line 2 was negative 2x plus 2 and line 3 was x minus 1. We'll set them equal and try to get the x's on the same side. We will take the x from the right side and move it to the left. When we move it, it will become negative x. This will give us negative 3x plus 2 on the left and negative 1 on the right. Then we'll take the positive 2 from the left and move it right. When we move it, it will become negative 2. Therefore, we now have negative 3x equals negative 3. Now we divide both sides by negative 3. This will give us x equals 1 if we simplify. Now that we have our x equals 1, let's put that into one of the other two lines. It won't make much difference which one. You have a choice which line you can plug it into, but it's easier to use the simpler of the two lines. Since line 3 looks a little simpler to me, let's use that one. Line 3 says y is equal to x minus 1. We'll put that x equals 1 in where we see x. Therefore, we'll have y equals 1 minus 1, which is 0. Therefore, our third vertex will be x comma y. The x we found was x equals 1 earlier. The y that we found was 0, and this will be our third vertex, 1, 0. Now that we've found all three vertices, let's try to sketch a graph. On this new page, I've written my system. I've noted that line 1 is horizontal and line 2 and 3 are both diagonal, and I've written all three of the vertices that we found previously. Now let's place the vertices on the graph. Our first vertex was negative 2, 6. We locate this on the graph. We'll go left to negative 2 on the x-axis and up 6 points on the y-axis. We'll place a dot at where those two locations would intersect. This is our first vertex. We'll also locate 7, 6 on the axis. 7 is just on the edge of the x-axis, and then we'll also go up by 6 and place a dot at that position as well. This is our second vertex. Our final vertex is 1, 0. We'll go right to where x equals 1 and let y stay 0, and this will be our third vertex. Now we'll try to draw lines that connect those vertices. First, we'll draw a horizontal line representing line 1. This will go through the first and second vertex. Now we'll draw a diagonal line for line 2. Notice that line 2 has a negative rate of change. Since we have a negative in front of the x, this means that this line will go downward as we go from left to right. This will be the line that connects the first vertex to the third vertex. Finally, we'll also connect the second vertex to the third vertex using the third line. Notice that it has a positive rate of change. Therefore, it's going to increase as we go from left to right, and it will connect the second and third vertex. Now we have the general shape of the graph. However, this will require some minor edits. When you're doing a system of inequalities, we'll need to modify the graph based on the symbols that are in the inequalities. Anytime you have a strictly less or strictly greater system, we replace the line with a dashed line. Less or equal or greater or equal means solid lines. If we look at line 1, we see a strictly less than symbol. Therefore, it is not correct to draw a solid line for line 1. Instead, we'll draw a dashed line. However, the other two symbols for line 2 and line 3 are greater or equal and less or equal. For that reason, we can leave those as solid lines. Now that we know the shape of the graph, we will try to figure out how to satisfy the inequality conditions. To satisfy the inequality conditions, we're going to shade either above or below each line. The direction we shade depends on the inequality symbols. If you see less than, you will shade below, If you see greater than, you'll shade above. If we look to line 1, we see that line 1 contains less than. Therefore, we will shade everything below line 1. We will shade that lightly in blue. Now, line 2 has greater than, so we're going to also make sure to shade above line 2. But when we do that, we're going to make sure we stay below line 1. We'll shade that in yellow, making sure to go above line 2, but don't go over line 1. Now notice there is a region on this graph where the yellow and blue cross. We're going to pay attention to that part. With that in mind, we're now going to handle line 3's inequality. On the next slide, I'm going to denote the part where the yellow and the blue cross. Now I've erased the extra blue lines for clarity. We're noting that we only want to shade above line 2, so any blue lines that were below line 2, I have removed. Now we pay attention to line 3. Line 3 has a less than symbol in it, and because it has a less than symbol, we must shade below line 3. However, we must make sure as we do so that we stay below line 1 and above line 2. We'll shade this in orange. Therefore, we note where line 3 is, and we'll shade below line 3, but make sure to stay above 2. As we continue shading, we must also make sure to stay below line 1 as well. Therefore, our solution set to this set of inequalities will look rather unusual. It's going to involve a certain part of line 3 that's in between line 2 and line 1. I'm outlining it in red now. It will also be the part of line 1 that's to the right, and it will also be the part of line 2 that's underneath line 3. Notice that this region is enclosed above and below and to the left, but not enclosed to the right. Because this region is not enclosed on the right, this region is called unbounded. Any region that is completely enclosed on all sides would be called bounded. However, because we have an open part to the right, this is an unbounded region for these inequalities. And so this is how we graph the solution to a set of inequalities. Just to review what we did here, for step 1, we found the vertices. Step 2, we drew the lines, and step 3, we shaded the regions. Once you've done all 3 of those, you'll have solved a system of inequalities. Thank you for watching, and we'll see you again soon.